Hello everyone. Today in this video we are going to discuss about one of the most important topic in JEE Mains and Advanced, matrix. At first we know about what is the matrix. Matrix, a rectangular array of numbers or symbol which is called matrix. Why need matrix in mathematics? In geometric, mathematics are widely used for specifying and representing geometric transformation, and also matrix is needed in numerical analysis for many computational problems are solved by reducing them to a matrix computation, and this often involves computing with matrix huge dimension. Then notation. Notation. Matrix can be written as, for a matrix A can be written as this is M cross N matrix. These elements A11, A12 up to A1n. Also second row A21, A22 up to A2 of n. This is continuously proceeding AM1, AM2 up to AMN, where for this case where 1 less than equal to I less than equal to M, and also I1 less than equal to J less than equal to N. It written as compact from. It written as the compact from A equal to A of Ij in M cross N. Otherwise, or it can be written as A equals A of Ij, or it can be written as A equals A of Ij of M cross N. Then where A of Ij equals, this is element of the matrix, ith row and jth elements of the matrix A, where M denotes row of A, N denotes columns of A. So what we know about this information? Suppose A be a matrix A11, A12 up to A1n, A21, A22, A2 of n, continuously ongoing, A M1, A M2, A Mn. This is the size of the matrix M cross N. M denotes the row, N denotes the column of the matrix. Aij element, suppose A11. This is 1th position and 2th position of the element of the matrix. and here M denotes the matrix row, and N denotes the column. Then we discuss about the size of the matrix. What is the size? This is M cross N. Possible order of the matrix. Order of the matrix A is M cross N. Suppose we consider a matrix A which is filled with 1 0 1 3 2 1 5 4 0 6 6 3. Let's consider an arbitrary matrix. This is 3 cross 4. 3 is row, this is first row, this is second row, this is third row, and this is denote the column 4. This is denote the column, first column, this is second column, this is third column, and this is also considered regularly fourth column. So here at first we find the order of the A. Order of A is 3. Also, if you find the elements in the matrix, A of 1 1 is -1. A of 3 3, we goes to 3 row and 3rd position of the column. This is the 6. So we can find a of 1 comma 3. If we A of 1 comma 3, we go to the first row and the third column position. In first row, third column position, we go to there, and this is the element. So this is 1. Next, we do a problem. A matrix has 143 elements. Then number of possible order of the matrix. About A be a matrix, how we solve this? At first, given the question, you look 143 elements. So A must be considered as, this is the matrix. In this matrix, 143 elements. So what is the possible order? Possible order is, given that 143 elements. So A be a matrix, what is the order? In this matrix, 143 elements. What is the possible order? Possible order can be written as 143 into 1, 1 into 143, and also is a divisor. What is the divisor of the 143? We can express it 11 into 13, and also it's opposite 13 into 11. For this 4 is the possible order. This 4 is the possible order. Now we discuss about types of matrix. Types of matrices. This is, for this case, some special type of matrix we know, which is help solve many problems for rather than small time. At first, we discuss the rectangular matrix. What is the rectangular matrix? Rectangular matrix. Let a matrix A equal to A of ij with m cross n is called a rectangular matrix. if m is not equal to n. What is implies? This implies that if A be a matrix with this m cross n, they are given a condition some element m not equals n. This is the given criteria for rectangular matrix. This is the given criteria for rectangular matrix. Next page. Second, we read square matrix. When it should be square? If the given matrix dimension is same, then this is the square matrix. So suppose matrix, if a matrix A equals Aij of m cross n is called square matrix, is called square matrix if m equals to n. What is implies? This implies that if A be a matrix, this is must, what is the given criteria? M equal to n. Suppose example, A be a matrix, this is 2 cross 2. Dimension should be same, m equals n. This is the given criteria. For this case, A11, A12, A21, A22. These 4 elements, we should take any of them. After that, number 3, row matrix. What is a row matrix? A matrix A equals A of ij m cross n matrix is called row matrix. It's called row matrix if m equals 1. M should be one dimensional. Then it is denoted by A equals, this is only one row, A11, A12 up to A1n. This is one row with n columns. This is denoted the column, first column, this is second column up to, this is n columns. This is one row. This is one. Next slide. 4. After that, what do we know? Column matrix. Let us consider a matrix A equals Aij m cross n is called column matrix if n equals to 1. What is implies that? Implies that A equals m columns, m rows but one column, m rows but one columns. So what you can consider the matrix A11, A21 up to AM1. This is the first column, this is second column up to this is m columns, and this is this is first row, this is second row up to this is m row, and this is about the first columns. And next slide we discuss about the column matrix. What is the column matrix? 4. Let a matrix A equals A of ij m cross n is called column matrix, if It's called column matrix if n equals to 1. If given condition is if n is equals to 1, so this matrix can be looked as A equals A11, A21 up to A of M1. This is M cross 1, M rows, 1 columns. This is 1 columns, first row, second row up to M rows. After that, we know about null matrix. What is null matrix? Let consider matrix A equals to A of ij M cross n is called null matrix if A of ij equals 0 for all I equals to j. All elements looks as 0, value is 0. For example, A equals to 0 0 0 0. This is null matrix. It's denoted as 0 matrix. Denoted as 0 matrix. After that, we can discuss about the diagonal matrix. What about the diagonal matrix? Let us consider a matrix, diagonal matrix. Let us consider a matrix A equals to Aij M cross n, where M equals to n. It should be square matrix. A square matrix is said to be diagonal if A of ij equals 0 for all I not equals to j. A square matrix is called diagonal matrix if all elements equal 0 but for all I not equal to j, but only diagonal elements would be not 0. It's look like as A equals to this is M cross Aij 0. Suppose that for all I not equal to j, this implies that A12 this is 0, A13 this is 0. All above diagonals and below diagonals, this is called above diagonals. Diagonal, this is diagonal, this is below. For this case, this is the below diagonal, and these elements is called the diagonal elements. This is called the diagonal elements. You should remember that for diagonal matrix, don't any kind of restriction with diagonal elements, but above diagonal, below diagonal, we have a restriction which is Aij equals 0 for all I not equals to j. This implies that Aij equals to 0 if I greater than equal to j, greater than j, or I less than j. Or also you can say Aij equal to 0 if I not equal to j. This is a given criteria for diagonal matrix. You should remember that diagonal matrix, diagonal elements is no restriction. Got it? 7 is scalar matrix. Scalar matrix, you should take at first a diagonal matrix. A diagonal matrix must be a square matrix. A diagonal matrix is called scalar matrix if all diagonal elements are equal. If all diagonal elements are equal. Elements are equal. For implies that if A equal to this, above diagonal, below diagonal, this is always 0 because this is diagonal matrix. In diagonal, this is same. For what kind value? A belongs to real number. This is called a diagonal matrix. For this, it also called diagonal matrix, but in diagonal elements all are same, so it can be scalar matrix. You should always remember, in diagonal matrix or scalar matrix, above diagonal and below diagonal, this is always 0. This is one restriction, but in diagonal, this is no restriction. For diagonal matrix, scalar matrix, in diagonal, one restriction, all elements should be same. After that, identity matrix. What is that? Let us consider a square matrix A equals to A of ij n cross n, each called identity matrix, if A of ij equals 0 for all I not equals to j, and A of ij equals to 1 for each I equals to j. This is a diagonal matrix. It can be written as A equal, it is written as A equal to 0 1 0 0 1. It can be written as I should match the given criteria. What is the given criteria? Aij equal to 0 for all I not equal to j. This is A11, this is A12, A13, A22. Sorry, A12. A11 for A11 value 1. A12, this is 0. For this case I not equal to j. For this case I equal to j. So this is 1. This is 0. Similarly, A21, this is 0. Here I not equal to j. A22, for this case we can see that value, what is the value? Value is 1. 1, there I equal to j. So all the given criteria is fulfilled. Then this is can be the identity matrix. Next slide. 9. Then we can introduce a new format matrix, upper triangular matrix. Let us consider a square matrix. Always we do in square matrix. A of ij with n cross n, each called upper triangular matrix. Upper triangular matrix. If A of ij equal to 0 for all I greater than j. So if A equal to this, a matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. What is the given condition? Aij equal 0 for I greater than j. I greater than j, this implies that this is goes to 0, this is goes to 0, this is goes to 0. So this is diagonal, this is above diagonal. All this above diagonal element is non-zero. Above diagonal, it should not be a restriction. All above diagonal not 0. One of them is 0, but all not 0. For below diagonal, all elements should be 0. This matrix So this type, this is the matrix, diagonal element, above diagonal none, but below diagonal must be 0. This is above diagonal. Similarly, we goes to lower triangular matrix. Lower triangular matrix. Let us consider a square matrix A of ij with n cross n, is called lower triangular matrix if given condition, if A of ij equals to 0 for all I less than j. How we treat that? This should be like that. Above diagonal is 0, but below diagonal you don't have restriction. It not be 0. Sum of elements is 0, but all elements should be not 0. This is a lower triangular matrix. The line along which they lie is called principal diagonal. Principal diagonal. After that, we read about two special type of matrix. One of this is real matrix. Real matrix, the name of the matrix, we consider that all elements should be real. All elements should be real. If all entries of A are real, this is called real matrix. Similarly, we consider that complex matrix. Complex matrix. What is complex matrix? If all elements entries of A are complex. Complex element look like A plus IB should be A equal to 0. This is no restriction, but this term is not 0, because if 0, then this is goes to real numbers. After that, we discuss about some properties of matrix. What properties we discuss? Some properties of addition, multiplication. Okay, at first we defined what is the addition, what is the multiplication, then we discuss about this. Let us consider a matrix A equals to A of ij with m cross n, and B be a matrix B of ij with p cross q. Okay, then defined sum A plus B equals A of ij plus B of ij with m cross n, where provided for define the matrix sum we should provided m equals p, n equals q. Same order we should know that. If we same order, then we define the sum. Also we defined difference of the matrix. Similarly, we define difference of the matrix. a minus b, this is equal to a of ij minus b of ij into m cross n. Given criteria is same. If this criteria holds, then sum and also difference multiplication should be exist. Scalar multiplication. Scalar multiplication. Alpha b scalar, which is gold. Then this is this. Some interested thing is we see that in multiplication. What is the interesting thing? For this case, here we should only provided n equals p, where a equals to a of ij, this is m cross n, b equals to b of ij, p cross q. Here only one thing provided, that these two elements have same, then multiplication is exist. If n equals to p, then matrix multiplication exists. So a dot b equals c of ij, one new coefficient. What is the orders? This should be same. This order is m cross q. What is the c of ij? C of ij is a of I of 1, b of 1j plus up to this ain b of nj, which is summation of a of ik, b of kj. Okay. How we get this term in our mind? Let a dot b. What is the a matrix? This is the b matrix. Suppose we write some element a11, this is a1n, a21, a22 up to a2n. This is continuously processing. A of n1, a of n m, b of 11, b of 12 up to b of 1n, then b of 21, b of 22 up to b of 2n. This is goes to b of m of 1. This is b of. This is what is the given criteria? This is m cross n. Always this is n cross q. So matrix multiplication, this first row with first column, a11 b11 plus a this goes to this. This is a continuous process. Then we get that c. This is c. This element. This is order m cross q. Then properties of addition of two matrix. If addition is whole, then some properties. A should be aij m cross n, b of ij m cross n. Also C be a matrix, C of ij m cross n. Then what is the property? 1. Property number 1, a plus b equals b plus a. This property known as commutativity. This commute each other. A plus b, b plus a. This commute each other. So this property is a commutativity. Property number 2, a plus b plus c equals a plus b plus c. This bracket will be associated. This property known as associativity. For any zero matrix, we know that zero matrix, what is a zero matrix? 0 of m cross n. This implies that all elements should be 0. All elements should be 0. This is m cross m, n cross n, or others. Then for a matrix of 0 and all entries 0 matrix, we should say that a plus 0 equals 0 plus a equals a. If a matrix A of any matrix, we addition with a 0 matrix, this is 0 matrix with this matrix order, then we get the same matrix. This is the property number 3. What is the property number 4? A plus of minus of a, this equals 0 equals minus of a plus a. This is existence of additive inverse. Why is called inverse? Because given a matrix A, this element goes to the 0. For this reason, this is called inverse. Similarly, some special properties of multiplication, matrix multiplication. Matrix multiplication, similarly, if A be a matrix, define that A of ij with m cross n, B be a matrix, B of ij is m cross n, two matrix with some scalar lambda mu be some scalar. Then the property number 1, lambda of a plus b equals lambda a plus lambda times b. Then lambda of mu a, this goes to lambda a plus mu times of a. Property number 3, 1 be a scalar and matrix multiplication with a, we go to the same matrix, and also minus 1 be a scalar with matrix multiplication a, then we get the minus of a. This is the some special kind of properties in matrix multiplication. After that, we goes to the one of the most important things. What is the transpose of matrix? Transpose of matrix. Transpose of matrix. Let us consider a matrix A equals to A of ij m cross n. Then by changing its rows into columns, and its column and its column its columns into row, then it's called transpose of A. Then it's called transpose matrix. It's called transpose matrix. Suppose we have a matrix A11, A12, A13, 21, 22, 23, F31, 32, 33. Then what is the transpose? By the definition, it should say that matrix change is row by columns. Here columns, this row goes to this columns, so A11, A12, A13. Second row goes to the second column, then this goes to A21, A22, A23. Third row goes to the third column, A31, A32, A33. If anyone says that, sir, its column also goes to row, okay, you should try this. See this. This is the column, first column, it goes to the row. A11, A21, A31. Also this second column, A12, A22, this is the row, this is the row. Satisfy the property, then this is called the transpose of matrix. Some more special type of matrix. This special type of matrix directly used in so many problems to help reduce the time in so many problems you can easily solve. At first, idempotent matrix. Also, you should work with square matrix. A square matrix. Idempotent matrix. Idempotent. If A square equal to A, then we call that this is idempotent matrix. For example, if you take A equals to identity matrix 1 0 0 1, for what is the given condition of identity matrix? A of I comma j equals to 1 for all I equals to j, or other case this is goes to a 0. So this is 1 1 1, this is 2 2, this is 1, all other case 0. For this matrix, if it's square, what is the square? This is matrix multiplication 1 0 0 1 and also 1 0 0 1. It is matrix multiplication. We see that this row, this column, this is 1 plus 0. Second row with second column, this is 0 plus 0. This also 0 plus 0. This is 0 plus 1. What is the final matrix? Final matrix is 1 0 0 1, which is nothing A. So by here we see that A square equal to A. So this is idempotent matrix. Also example, any of 0 matrix, if A equal to 0, then we say that A square equal to 0. This implies that A square equal to A. This is also a idempotent matrix. Many of example you can see that. Okay. Then second special type of matrix, involuntary matrix. Involuntary matrix. Let us consider ABA square matrix. If A square equal to I, then it's called that involuntary matrix. So A square equal to I means identity matrix, where I means identity matrix. This is identity matrix, you can say that. Then this is called a involuntary. So here we can say that A square equal to I. This, for example, I, this also square, this is also I. So this is I is identity matrix, also involuntary, because it satisfies all given criteria for involuntary matrix. Third case, nilpotent. A matrix, a square matrix A, is said to be a nilpotent matrix if a to the power k equals 0 for some k belongs to natural number set. Then this is called the nilpotent matrix. For this k, what is the given condition? K belongs to natural number. If k is the smallest positive integer, note this is most important. Many of questions asked from there. If k is the smallest positive integer, if k is the smallest positive integer, such that a to the power k equal to 0, then this k is called index. Then k is called index of nilpotent matrix. This is most important. For nilpotent matrix, a to the power k equal to 0, k belongs to natural number, smallest positive integer k. For this case, k is called index of nilpotent matrix. Also note that if a to the power k plus 1 equal to a, for some positive integer k, for some k belongs to positive integer, then this list value of k is called period. This k is called period. This is enough for that theorem today class lecture. Let us take some problems. The basic concept of matrix. Then we discuss about some problem for this concept only. If A be a matrix M n cross R with real entries, this means this is real entries, for n greater or equals to 2, then which of the following is or are true? 1. If a square equal to 0, then a cube equal to 0. Second, if a cube equal to 0, then a square equal to 0. Third, if A be a 2 cross 2 matrix, a q equal to 0, this implies that a square equal to 0. 4. If a square equal to I, then a equals to I or a minus I, a equal to minus of I. Okay, then for this problem, which of the following is true? This is 4 case. For first case, he said that if a square equal to 0, if a square 0, then a cube equal to 0. Given condition for first case, a square 0, what you find? You find that a cube. You do work in a cube. What we can write is a cube in matrix multiplication. a square, aq can be write as this. What is the value of a square? A square is 0. This is 0 into a. This is multiplication. Any of matrix with multiplication with 0, this also goes to 0. By another way, you can say that aq equal to a into a square. This is also a dot 0 equal to 0. So first option should be true. Next, we see about second option. What is the second option? For second option, we can see that given is, what is the given condition is aq equal to 0, then a square 0. Okay, aq is 0, but then we prove that a square equal to 0. This method does not hold because we goes to lower dimension to higher dimensional, but we don't go move forward higher dimensional to lower dimensional. We know that if a given condition is false, then let us find a example by proof its example. So let us consider if A be a matrix aq equal to 0, 0, 1, 0, 0, 0, 1, 0, 0, 0. This is 3 cross 3 matrix. If we a cube, then we can see that a square. What is the a square? A square is this matrix 2 times multiplication, 0, 1, 0, 0, 0, 1, 0, 0, 0. Also 0, 1, 0, 0, 0, 1, 0, 0, 0. This row by this column, you can see that this goes to 0, 0, this is 1. This goes to this, then 0, 0, 0, this is 0 goes to 0. Then how we find that? A cube equal to, what is that? A cube, a square into a. What is the value of a square? 0, 0, 1, 0, 0, 0, this is 0, 0, 0. And also this 0, 1, 0, 0, 0, 1, this is 0, 0, 0. This is a square, this is a, from this case we can go that a cube. So if we multiply that, this goes to this goes to this. For second row, it goes to second column. Third row, it goes to third column. This is 0. All terms is 0. This implies that this is 0. So a cube 0, but here how we calculate that? This is a square. This is a square. This is a cube 0, but a not equal to 0. Also, a square is not equal to 0. So what there? Second case is also false. Second case is also false. Similarly, you should try same type of this. This is false. This is also false. This, why this is false? For 4, it said that if a square equal to I, this only possibility, this says that a equal to I, a equal to minus I. This is wrong because most of the matrix satisfies this condition. This a not equal to I, a not equal to minus I, but a not equal to minus I, but a square equal to I. For this reason, this is false statement. These two are trivial, but so many non-trivial matrix here holds. For this reason, this is false. Some problem. First problem. What is the represent of In? What is the represent of In? This is identity matrix. The basic problem. If second problem, if number of rows equal to number of column, then this matrix is said to be what type of matrix? A matrix is given number of rows, number of column is same. So this is M cross n matrix, M equal to n. What type of matrix? This is square matrix. This is square matrix. For this problem, you see most of concept is clear. If a matrix, if a square matrix, A of ij equal to 0 for all I greater than 0, then it said to be dash, where as if A of ij equal to 0 for all I less than j, then it is said to be dash, and if A of ij equal 0 for all I not equal to j, then it's said to be dash. So first condition is this, respect to this. Second condition is this, respect to this. Third condition is this, respect to this. Find. At first you should be write a matrix A. If A of ij equal to 0, this is diagonal element, this is above diagonal, upper diagonal, this is lower diagonal, below diagonal. Here say that A of ij equal to 0, first condition, I greater than j. First condition, I greater than j. So this is A11, A1, this is A of M1. This is a diagonal element. This I equal to j. For this case, this is I less than j. For this case, this is I greater than j. So all of these elements are 0. But in above, this is no restriction. So this is should be upper triangular matrix. Upper triangular matrix. For second condition, this first. For second condition, A is this matrix. This is diagonal. This is I less than j. This all elements are 0. So this is lower triangular matrix. Lower triangular matrix. For third condition, what we said that A of ij equal to 0. All ij, I less than j 0, I greater than j is 0. For third case, I less than j 0, I greater than 0. But for this diagonal element, this is not restriction, this is not 0. At least not 0. One of them 0, but this is not 0. None of them 0. None of them. Then this is called the diagonal matrix. This is called a diagonal matrix. This is also most important problem. So many times asked in some good exams. Maximum number of the distinct entries in triangular matrix of order n. You first write a triangular matrix. If this is 0, this is the upper triangular matrix. This is also a kind of triangular matrix. If this is 0, this is the lower triangular matrix. This is must be a square matrix n cross n. Then question is given that maximum number of distinct entry in triangular matrix of order n. Maximum number of distinct entry. At first, what is a order of the matrix? Order of the matrix is n into n. This implies n square. This is upper triangular, this is lower triangular. So triangular matrix, what is a triangular matrix? Triangular matrix, these two sum only diagonal elements are here. Both are 0. This is a triangle. So for this case, what is the maximum number of distinct entries? This n elements are distinct. Order is n square. In n square elements, how many are distinct? N square minus this is n by 2, this is n by, this is half region, this is half region, and also this all elements are 0. So this goes to n square minus n by 2 plus n plus 1. Why this one? This one goes only for 0. This is only for diagonal elements, or this goes from this upper triangular and lower triangular. Since n square elements in all of the matrix, for this case, for only this case, n square minus n plus n square minus n by 2 plus n plus 1. If some of most important question you asked for nilpotency, you solve this. This is last problem. If ABA n cross n, BBA n cross n, BB n cross n are nilpotent matrix. These two are nilpotent matrix. Then which of the following are true? 1. A plus B or AB is nilpotent. AB is nilpotent. Either. Second case, either AB or BA is nilpotent. Third condition, if AB equals B of A, then A plus B, AB, BA are all nilpotent. Fourth problem, A to the power m is nilpotent for all m belongs to natural number. For this case, how we solve this problem? First, given criteria is A and B are two nilpotent matrix. This is a given condition. So at first you write this given condition. What you can say that by induction we can say that A, B to the power k equal to this for k belongs to natural number. Okay, so this is nilpotent matrix, this is nilpotent matrix. For some k belongs to natural number, this goes to 0, this goes to 0, so this always goes to 0. And for this case, AB square equals AB into A of B. So this is, if we rotate this, A square B square. Okay, so here we can see that AB to the power k whole to the power k equal to AK BK, and A is nilpotent matrix, nilpotent, so A to the power k equal to 0, some k belongs to natural number. Also B is nilpotent, so B to the power k equal to 0, so this property holds. It implies that third is true. Then if we notice that A is nilpotent, given condition A is nilpotent, A is nilpotent, this implies that A to the power k equal to 0, we can rewrite it since k belongs to natural number, it is multiplicity of this 0 to the power m equals to 0. This can be written as a to the power k whole to the power m. So this is by the given condition, by definition of nilpotent, this is goes to 0, 0 to the power m, this is 0, this is anything of 0. This given condition for all m greater than equal to 1. So from there we can say that a to the power m to the power k equal to a to the power k to the power m, this goes to 0 by a definition of this is 0. So here last option is true. Third and fourth is true, rest of them is false. Okay, these are all problems. Also there are so many problems happens in the matrix. Okay, thank you.